Welcome to December 27th LeetCode Challenge. Number complement. The complement of an integer is an integer you get when you flip all the zeros to ones and all the ones to zero in its binary representation. For example, you have integer 5, 1, 0, 1 is its binary representation, and its complement of that is 0, 1, 0, which is integer 2. Given the integer num, return its complement. So, similar to the example given in the question, example 1 here tells you that you have an integer 5. Its binary representation is 101. Its complement is 010. It's by the binary representation of that number, and then you convert it back to an integer, which is 2. So example 2, you have a number of 1, its complement is 0, therefore the number is 0. That's pretty much it. The constraints are between 1 to 2 to the 31st. So this is labeled easy, but at the end of the day, you kind of have to know about complements and binary numbers to kind of even start on this question. I mean, it's pretty basic level, but just assuming that you guys know that. So let's go. An easiest approach would be to convert everything to a binary representation. Let's go for something like this. So, but the binary representation. So you could use like a string formatting thing, but I'm just gonna use. Yeah, let's use string formatting because. So it'd be 0 hyphen 0b. So this is just formatting the num into a binary form, which is a string, of course, and then we're going to make an empty string where we can append our answer towards 2. So for each index in our binary representation, if the index is equal to the character 1, we are going to append 0. Else, I mean, the only thing else it could be is a 1, a 0, so we're going to append a 1, character 1, I should say. Then when we want to return our return string, as an integer, I should say, and we want it in binary form. That's what this 2 represents, binary, 2, binary. Also in the code. Oh, that needs to be a character. Submit. Okay, that works. So that would be like big O of n because it iterates through it, right? And space, as for space, time complexity, space complexity is constant memory because we don't really use any memory. Actually, we do, but it's constant because we store it in a string. All right, is there a better way of doing this? The answer is yes. So basically, we could use the bin notation as well. So we could do bin of num. However, for instance, if you use like bin 5, for instance, that will give you something that looks like this, right? And we don't want that 0b in front of it. I mean, it's telling you that the binary is 5 is a binary representation. The binary representation of 5 is 0, 1, 0, but you don't want these first two characters, so what we're going to do is take the slice of it. Alright, and that will give you the correct number. I'm not going to assign it just yet. The next thing we need to know is a little bit about Boolean logic, so specifically the XOR logic. So a little educational lesson for you guys here today. So we're going to use what's called XOR or exclusive OR. So that basically tells you that, for instance, you have two parameters inputted. You have 0, XOR 0, that will be giving you 0. You have 0 exclusive OR 1, that will give you a 1. You have 1 exclusive OR 0, that will give you a 1. And then you have 1 exclusive OR 1, that will give you a 0. So from this kind of logic right here, if we use XOR logic, we can get this answer. and therefore we're using fancy stuff with solving this question. So let's go about doing that. So given the number, right, we have num. I'm just gonna put it down here. So first thing we want to do is find the length of our binary number, right? We got that. So the length of it, and then we are going to multiply that by the character 1. Right? Got that so far. And this is basically going to be our string. Right? Our string, what we want. So the length 1 star 1 is for creating the same length of 1s to each XOR element that we are going to XOR with in terms of nums. So for example, oh, this is supposed to be a 1. So let's see. We noticed a couple of things here. Let's look at this. Actually, let's erase XOR of 0 and look at this. So we see if we have the length of all 1s here, which everything is going to be 1. If we XOR with itself, right here, any 0 will become a 1, and any 1 will become a 0. And that's exactly what we need, right? So we have made all 1s, the length of all 1s in nums. The only thing we need to do now is use the XOR notation. How do you do XOR? XOR in Python is using the caret operator with itself, with nums, right? And that's basically pretty. Oh, we have to convert this to an integer, I should say, and we want the integer to be binary, and we want to return it. All right. Let's see if this works. Submit the code. Accept it. Awesome. So basically what we did was that we took the number, we XORed it with itself, but the XOR we did was that we took the integer, we multiplied each length of the nums by 1, and we called it, we made it in binary. So anytime that nums would be XORed with itself, with 1, it will return the complement of it. Essentially, that's what we did. Alright, that's it. Have yourself a great day. This is using bitwise operation, by the way. Exclusive OR. Alright, take care.